Welcome to Tech Consult. Today we shall be discussing distribution and utilization of electricity. Now, by the end of this lesson, I expect you to be able to define distribution of electricity, also list different channels through which distribution of electricity can be done. Right. Also, I also expect you to, highlight different systems of distribution of electricity and different components of appliances that we have in our homes that can utilize electricity. Okay, sit back as we progress. Okay, so what actually is distribution of electricity? Just like we've said in my previous video about generation and transmission of electricity, we said that electricity is first of all generated in generating plants or power plants. This electricity generated is transmitted, right? It's transmitted at a very high voltage along the transmission lines. Now, this high voltage power that's been transmitted, they are brought to the substation where we call the distribution station. In that distribution station, what happens is that this electricity that is at very high voltage, we can have like up to 330,000 volts of generated electricity. Now, in this substation, in the distribution substation, it will be stepped down. Some of them will be stepped down to different voltages. For example, we can have it at 11,000 voltage. It can be stepped down depending on location, depending on the people that are consuming the electricity. It can be stepped down to 33,000 volts, can be stepped down to 132,000 volts, depending. That one is the one supplied directly to the industries, to companies, or to what we call factories, because they need high voltage to power their plants. Okay? Now, at the distribution substation, now this electricity generated can now, be stepped down, pass through different series of step down transformers before it can get to the end users. So, electricity distribution, therefore, is the process by which electricity is delivered to the end users. The end users in this case include homes, offices, churches, mosques, name it. Some businesses, fast foods, restaurants, and hotels, these are end users of electricity. So when electricity is distributed to these end users, we say electricity distribution has taken place. And that's why we have the discos in Nigeria. They are called distribution companies in Nigeria. We have the GENCOs, people that generate electricity. That is the electricity structure in this country, Nigeria, and all of that. Now, the distribution is what we want to talk about. How does it happen? Through which process does it happen? All right, so we say we have different channels of electricity distribution. Number one is what happens at the substation. The moment the high tension or high voltage electricity is being brought to the substation, that's the first place. This substation is the distribution station. It will be stepped down. Now, stepping down could be from about from 33 kilovolts to about 11 kilovolts. When I say kilovolt, it means 33,000 volts. I've said that before. Now, from these substations, this step down electricity will move or will be passed to the distribution lines, because we have transmission lines, we have distribution lines. In a normal Nigerian pole, those lines that are not on the top of, right, the major pole you have, the main pole you have is actually the distribution line. We have the ones that still have up to 11,000 volts. Then we have the ones that have been stepped down to about 230, 240, depending on the phase that will now go to our houses. Now, that line, we have to also move them to distribution lines, where it will be carried from the distribution substations to people's houses. Now, from the distribution lines, it will enter the distribution transformers. In these distribution transformers, what happens there is that this 11,000 volts that is coming from the distribution channels will be stepped down to about 230 to 250 volts, because this is the voltage that the appliances in our homes can actually tolerate. If not, they will burn. All right? So when this happens, all right, when I said 240 volts, that is depending on the phase. We'll still get there, right? We'll still have some of them also, step down to about 415 volts. This one is supplied to factories and so on and so forth. Now, after this is being stepped down in the distribution transformers, then it will be connected to the service people. It will be connected to people's homes. Then you can now tap from the wire to your houses. Now, there are two systems that electricity can be supplied to our homes. And that system is what we call a single-phase three-wire system. I'm going to show you what it looks like. We have the three-phase, four-wire system. In single-phase three-wire system is just a system of electricity supply to certain locations where we don't have many people in that place. Maybe in some villages, we can supply a single phase three wires. And these three wires, the wires are neutral, the earth, and the life wires. These are three wires that enter into your building from the service line, right? From the service line. These three wires will enter your building. Now, if you just have one phase, that is the alternating current entering your building, will just have one phase. So if light goes from this phase, you will not be able to get light. So unless there's light in that phase. Now, this supplies electricity from about 230 volts to 240 volts. But in situations where we have clusters of people, we have a lot of people in that area, let's say in urban areas, or maybe we have such areas industrialized too, right? Then three-phase, four wires will be required most by these areas. The voltages in these areas will range from about 415 volts to 550. That is the highest it can go, about 415 to 500 volts of electricity supply in this case. Now, in the three-phase four wires, we have the four wires, we have the three phases, the life, and the neutral, like that. But for single-phase three wires, we have life, earth, neutral that enter into the building. But for three phases, we have life, three wires are life, then the fourth one is the neutral. So once we have the AC entering your building, is separated into these phases. So in this transmission line, in this distribution line, if there is no light here, you can change to this light, to this phase. If there is no light in this phase, you can change to this phase. That's exactly what happens in most Nigerian homes today. You say, hey, go and change the phase. That's what they are talking about when they say that. Okay, now see exactly what we are talking about here. These are different channels that it will go. Of course, it will go through this to step up transformer. You see, when we say pylons, this is what we mean by the towers, right? This power generation side, it will be stepped up, then sent through this transmission line to this line. Can you see that this is 3 phases? This is 3 phases. Then to substations. This is where you have your bus bars, your circuit and transformers, where this, you see, can be stepped down. That's what is playing out here. Can be stepped down to from 69 kilovolt to 132 kilovolt. Also to the distribution substation, like you see here. From these substations, we are going to have this step down further, and then being distributed to the industries. We have from 11,000 kilovolts to 3,000 kilovolts, 3 phases. Then to residential buildings, we have from 400 to 230 volts. That is single phase, 3 wires in this case. But we can also have, in some crowded areas, we can supply them 3 phases, 4 wires. Please, you have to take note of that. Okay. Now, this is a typical example of what I am talking about here. This typical example of what I'm talking about phases. This is a single phase 3 wires. This is the live wire, the neutral wire, and the earth. The earth here is not visible, but we have the earth wire. This is live wire and neutral wire. Then the next is earth. Then we also have from the distribution line, we have the live, neutral. In this case, this wire is red, yellow, blue, and neutral. Enters your building this way. Okay, we have 2 types of consumers. We have 2 types of consumers of electricity. The people that utilize electricity, there are about 2 types. There are domestic consumers and commercial consumers or industrial consumers. Now, domestic consumers are those ones that just make use of electricity, right? Just for normal domestic uses, charge their phones, play radio and watch television, plug in their washing machines. But we have industrial or commercial uses, those that use it to power their production plants on their machines and all of that. And they consume more and they pay more of electricity. Okay, now there are different control equipment we use for supplying electricity to a building. Now, this electricity that is coming from the distribution line, the first place it enters is what we call the ceiling box. It enters this ceiling box like you're seeing the cursor pointed. Now, from the ceiling box, the next thing it does to enter is it enters to the energy meter. The energy meter here is the meter that reads amount of energy that you consume. From there, it enters to the distribution box. From the distribution box, where we have different switches, different fuses for different rooms and partitions. Then once this electricity is connected to different fuses, then you have electricity supply in your homes and you keep enjoying electricity. Now, there are different household appliances that actually make use of electricity. They include the radio, the television, the fans, everybody knows about this, the toaster, the electric iron, the refrigerator, and blender. These are different household electrical appliances that utilize electricity in our homes. Thank you. As we go through the ExamGuide app, I need you to stay put. Let's see the questions from this as we have taught. Let's look at this. A transformer is said to be a step down if the secondary winding is dashed to that of the primary winding. A transformer is said to be a step-down transformer if the secondary windings is dashed to that of the primary windings in the transformer. I've told you before, if it's a step-down transformer, number of windings in the primary coil will be greater than that of the windings in the secondary coil. So in this case, the windings in the secondary coil is less than, yes, is less than in this case. Do you see that? It's less than in this case. Okay. He said, which is the mostly used AC supply system in Nigerian houses? Which is the mostly used AC system in Nigerian houses? Is it a single phase 2 wires? Do we have anything like that? We don't have anything like that. So A is eliminated. We don't have single phase 2 wires. E is eliminated. We don't have it. We don't have 3 phase 3 wires, but we have single phase 3 wires. We have 3 phase 4 wires. Which one is actually utilized in Nigerian houses widely? Is it a single phase? Is it the 3 phase in Nigerian houses? Which one? So basically, single phases are for buildings, they are for individuals. But 3 phase 4 wires are for industries, they are for factories. So for Nigerian houses, this is the right option for that. Thank you and God bless you.